Regvue, the modern hardware and software interface, HSI documentation. Introduction. The current state-of-the-art for register document is lacking. Register document is often in form of the Word document, PDF, or static HTML. These mediums are highly static and can be difficult to share. Want to automatically code the register value into field, these mediums won't help you. Want to share a specific part of the document with a colleague. With Word and PDF, you will need not only share the document, but also the section number, heading in the case the number change in future. Your colleague will need to download the document and make sure that they have an extra viewer installed, open the document, and then manually navigate to the relevant section. The Regvue addresses all of these shortcomings and more. Regvue uses modern web-based technologies to provide a more rich register documentation experience. Chapter 2. Features. Regvue provides several features that optimize the register documentation experience. These features save time, reduce bugs, and reduce mental load. Figure 1 provides an overview of major graphic elements of Regvue. Figure 1 is Regvue, and the Regvue implemented the incremental fuzzy search feature shown in Figure 2, and allows users to find an information they are looking for quickly or without leaving the keyboard. These features search various attributes like names, description, and offsets by various elements like blocks and registers and fields. Such search suggests and updated and provided as user types. Recent search sections are also presented to provide easy access to common reference element. Field, register, and encode-decode. Regvue automatically encodes the field values into register and values and decodes the register values into field values. For example, if user want to construct register write value, they can enter the value they want to write to each field, so the register value is automatically updated in real time as the user enters each field value. The user can then copy and paste the register value to write. Similarly, if the user wants to be a decoder register read values into values, they simply copy and paste the register read value into Regvue, and it automatically updates the field values. Figure 3 illustrates how it works. And Figure 3 is the field register encode, decode, and enumerated values. Byte swap. The Regvue provided the ability to toggle by swapping between the field values and register values, vice versa. This is useful in one venue. For example, design and verification uses a little endian, while another value, for example software, uses a big endian. Enumerated values. Regvue supports the enumerated value, which maps raw field values to more meaningful symbolic values, vice versa. For example, instead of seeing a value of 0x0 for the state field, the user will also see that it maps to a symbolic value like idle. With a long underscore comment field in the Figure 3 for an example. The multiple bases. Regvue supports representing field and register values in binary, decimal, and hexadecimal. The base is selectable via the DH button group. The multiple and optional reset. Regvue supports the multiple reset per field. For example, a field may be affected by both power and reset and PCI reset, while another field may not be affected by any reset. If a reset is not affected by the selected reset, it will be shown as one or more question mark. An example of this shown in Figure 4. Figure 4, multiple list sets. Direct permalinks. Regvue provide permalinks or links that never change the link directly to various elements like blocks, registers, and fields. Gone are the days having to provide all of a link to the document, a section numbers, and a section title. Hosting. Like if you have a minimal web hosting requirement, a basic static web hosting service like GitHub Pages or a GitLab page is sufficient. It can even be run on local host with a basic static web server like provided by Python. 3. Usage. Input format. Regvue is a design-agnostic web application. Design substitute register information is loaded from one or more JSON, JavaScript object notation files. See listing 1 for a small example. That the register description format, RDF schema. The RDF schema was created specifically for log. So the RDF takes some inspiration from the CMSIS SVD Common Microcontroller Software Interface Standard System View Description file format. The motivating the vector behind the RDF was minimizing the amount of post-processing necessary. Regvue uses JSON because Regvue runs on the JavaScript engine, and the JavaScript have native support for deserializing JSON into an object. Using an XML-based format like CMSIS-SVD or IPExec, it would have required more complex XML parsing using the DOM parser web API. Using the JSON-based format makes parsing a single call to JSON.parse JavaScript API. RDF JSON supports including other RDF JSON files. This enables higher level views to be constructed out of the lower level views. For example, a system level RDF JSON can include multiple chip level RDF JSONs, which can in turn include multiple module level RDF JSONs. This is listing 1 is a small but a valid RDF JSON document. Schema. The RDF JSON format is described using the JSON schema standard. Regvue uses RDF JSON schema to validate RDF JSON documents. For example, if a required property is missing, the validator will report an error, and Regvue will present the error to the user. And RDF JSON writers can also use the RDF JSON schema directly without Regvue to validate their RDF JSON generators. The RDF schemas include the schemas in versioning the information to enable breaking changes to schema in a backward compatible manner. So for example, the future version of a schema could add a required property. Existing RDF JSON document to be incompatible with this new schema, but since every RDF JSON document contains schema version information, Regvue could support both the old and new version of a schema, and thus support the RDF JSON document that can either version. For the web application, the Regvue web application instance is deployed to a static web hosting service by simply copying the necessary file to directory. The instance is now available via URL. So a single deployment can serve arbitrarily many designs. A user can load the Regvue application by navigating to instance URL. The user will be prompted to load an RDF JSON as shown in figure 5. is Regvue. Welcome to Regvue. The user can load the RDF JSONs from an URL or via the file system. The URL method is preferred because it supports included and is more easily shared with others. Loading via the file system does not support includes because of the file origin are treated by the same origin policy. A security policy implemented by a modern web browser. After loading an RDF JSON via an URL, Regvue will display the design home view and update the browser URL to a permalink that includes the path to the RDF JSON. The user can copy and share this URL with others to take them to the same view. Figure 6 shows a permalink that directly opens REGAI-A1 register from the example.com data.json RDF JSON file in Regvue at https://example.com. At JPL, we use GitHub Enterprise to host both the Regvue application and the Regvue JSON. More specifically, the Regvue application is hosted on the GitHub pages, and the Regvue JSONs are hosted directly in Git repository on GitHub Enterprise. The Regvue team is maintaining the Regvue application instance of GitHub pages. Regvue users are encouraged to use this instance but are free to install and maintain their own. Users can generate their Regvue JSON, then commit and push them directly to Git. This has 3 benefits and 1 drawback. The first benefit is that it makes it really easy for users to log the JSON. They simply push it to GitHub and load GitHub raw link for the Regvue JSON into Regvue application. Users do not need to procure the web hosting, nor do they need to know how to use GitHub pages. The second benefit is the users get versioning for free. The GitHub information is embedded in the URL of the Regvue JSON. If users wanted to load a different version, then simply modify the URL. The third and final benefit is the users also get authentication for free. Access to the Regvue JSON is controlled by normal GitHub access controls. The drawback of hosting the Regvue JSON directly in Git is the security policy of the modern browser, and GitHub means that the Regvue application must be hosted on GitHub as well. Regvue used the browser fetch web API. This API obeys a single origin policy, which makes it so that you can only fetch things from the same domain or origin. For example, if the Regvue is on GitHub, it can only fetch URLs that are also on GitHub. Or, to put to another way, to fetch a URL from GitHub, the fetch must occur from GitHub. The cross-origin resource sharing (CORS) standard provides a way to relax a single origin policy. However, the course configuration for GitHub raw links does not. The section the usage on a Europa Clipper. Regvue was developed and used for Europa Clipper mission. Europa Clipper is a spacecraft that will study Europa, an ice ocean moon of Jupiter. An existing in-house register automation tool called Register Translator was updated to generate the RDF JSON used by Regvue. Register transistor was that used to auto-generate the RDF JSON for most of the FPGA designs on Europa Clipper. So the two FPGA design required writing an ad hoc Python script to parse FPGA design specifications that were not compatible with the register translator. A top level of RDF JSON for the space flight computer or Europa Computer Element ECE was created with a simple shell script. The top level ECE RDF JSON simply includes the FPGA level RDF JSONs to provide a similar system level view of the spacecraft computer. Figure 7 shows the process of generating the RDF JSON for Europa Clipper. This is the figure 7 is generating the RDF JSON for Europa Clipper. Section 4 is implementation. Open source. Regvue is currently the process of being released as open source under the Apache 2.0 and the MIT licenses. When the Regvue has been released as open source, it will live under the NASA JPL GitHub organization. Technologies. Regvue is implemented with the TypeScript in the Vue front-end framework. TypeScript is basically JavaScript with types. It compiles down to the TypeScript is basically JavaScript with types. It compiles down to JavaScript, so the TypeScript was chosen to both catch more bugs at compile time and to improve maintainability. With a dynamically typed language like JavaScript, you might write a function takes an array as an input. If you later call the function and pass a string, JavaScript will throw a runtime error. Ideally, this is found during test, otherwise the error may be seen by the user. In TypeScript, such a mistake would be found at compile time. A front-end framework like Vue allows front-end web application to be written at a higher level of abstraction than raw HTML plus CSS plus JavaScript. Vue has the concept of a component which encapsulates a UI element. In Regvue, for the example, the search functionality is a component, so that the address map is component, and etc. Components can be instantiated inside of other components. And the Regvue, for example, register layer component is composed of several other components for the field labels, field values, and register value. The component abstraction makes it a lot easier to implement complex behaviors. Prior work. The idea for Regvue originated from a desire to graphical peek and poke registers in live hardware. You'd be able to explore the design much like the File Explorer, the application in Windows. We called it a Register for Explorers. We started the prototyping the GUI for Register Explorer. The first prototype was desktop application written in a Python and TK GUI toolkit. The register layout view is the most complex graphical portion of the application. It was the price to make or break the GUI, so it was always the piece to implement first. Implementing the register layout in TK required too many hacks and didn't work very well, so it was at this point, a realization was made. Register information is documentation. Trying to hand implement the render for documentation was silly. The best solution for interactive documentation today is HTML. A small prototype of the register layout was created in an HTML plus CSS JavaScript that implemented dynamic rotation of field labels depending on the field name length and a table cell width. This worked very well and confirmed that we were on the right path. A third prototype shown in Figure 8 was created to integrate the HTML prototype into Python TK GUI. The idea was to replace the custom TK-based register layout rendering with an embedded web browser. This, too, worked quite well. Figure 8 is the Register Explorer prototype of the TK GUI in an embedded web browser. The problem, however, was packaging the support of the embedded web browser. We used the CF Python library, which provides Python binding for the Chromium embedded framework, which effectively allows Chrome web browser to embed it in an application. We needed to support the 3 major operating systems and create an installation package for each. And we were enabled to find a turnkey solution to do this for CF-Python. Additionally, CF-Python is unevenly supported due to the lack of consistent funding. The path forward was not clear. We'd make it a web application. It could be accessible by any web browser, and we could use something like Electron and to deliver a desktop version with additional functionality like interacting with the live hardware. So the Rope created a very rough prototype of Regvue, demoed it internally at JPL, and secured for funding to Josh as a summer intern, make Regvue what it is today. Section 6 is future work. The original desire was for a GUI to manipulate the Explorer registers in live hardware. We now have a web application but no desktop application. As mentioned previously, something like Electron could be used. The problem with Electron, however, is that a package size is too large. Every installer ships with a full version of the Chromium web browser, which makes every Electron application 100 megabyte more. Enter Tauri. Tauri, like Electron, allows desktop application to build using web technologies. Unlike Electron, however, Tauri uses a web view provided by the operating system. Because of this, Tauri applications are much smaller, 1 to 2 orders of magnitude smaller. We've created a working prototype of a Regvue desktop shown in Figure 9 that can read and write registers over a UART serial console. However, there is still much to figure out before it can be deployed, let alone made public. Figure 9. A working prototype of the Regvue desktop. Acknowledge and the references here. Today, I'll add this paper, the Regvue, the Modern Hardware Software Interface, HSI documentation from DVCON2023. Thank you for your time. See you next time.